In this question, we have to sketch a rough graph of the given polynomial. I want you guys to remember that f of x can also be called as y. So here, the polynomial f of x is given to be 2x minus 1 times x minus 5 squared times x plus 3 times x minus 6. So the polynomial is given in the factored form. The best part about given a polynomial in the factored form is that you can easily find the x-intercepts or the solutions. Okay, so let's find the solutions of this polynomial. The solution, another word for solution, is also zeros. The zeros or the solutions of this polynomial. So what we try to do is we equate each factor to 0 and solve for x. For example, from the first factor, if I try to equate 2x minus 1 is equal to 0, to solve for x, I have to add 1 on both sides. So I get 2x is equal to, adding 1 on both sides, I get like that. And then to cancel the 2, I have to divide by 2 on both sides. So I get x is equal to half. Okay. So that's how I find the zeros. From each factor, I set it up to 0 and solve for x to find the zeros. So here, instead of x, if I put 1/2 instead of x, 2 times 1/2 will be 1 and 1 minus 1, which will make this factor a 0. So if you try putting 1/2 here, let me show you. 2 times 1/2 minus 1. 1/2 and half, 2 and 2 will cancel, and then you'll have the 1 left here, so 1 minus 1. So when you plug in 1/2, it makes this factor, the value of this factor, as a 0. That's why it's called a solution. So from the first factor, we have 1/2 as a solution. From the second one, -5, it's cancelled by +5, so 5 is a solution with multiplicity 2 or degree 2. Here, this factor, the degree is 1. From the next factor, if x plus 3 is a factor, +3 is cancelled by -3. So -3 is a solution. -6 is cancelled by +6, so +6 is a solution. And the degree of 3 is 1, and the degree of the individual factors are listed over here. If there's no number up there, it's a 1. So we have 3 factors in the first degree and 1 factor in the second degree. Now, in order to understand the shapes, there are 4 basic shapes that the polynomials can have. They either the degree of the total polynomial could be an even number or an odd number. The degree of the total polynomial. For example, here, what's the degree of this f of x? What's the degree of f of x here? You add up the degree of the individual terms. 1 plus 2 plus 1 plus 1 is 5. 2 plus 1 is 3, plus 1 is 4, plus 1 is 5. So the total here, the degree is 5. So we can say that this degree is 5, so it's going to fall under this column. Now, you should also look at the leading coefficient. The leading coefficient means the product of the first coefficients here. So if you multiply 2x times x times x times x, leading coefficient in the sense that it's the first coefficient. So 2x times x is 2x squared times x is 2x cubed times x is 2x to the 4th power. So 2x, here you have a square. There's 2x here because the degree is 2. So this is a square. So 2x is the leading coefficient here. X squared is the leading coefficient here since the degree is 2. X is the leading coefficient here and x is the leading coefficient here. So when you multiply all the leading coefficients, you get 2x to the 5th power. So the leading coefficient is 2, or it's a positive number, positive 2, not a negative 2. So we can say that the leading coefficient is positive in this case, right? So the degree was odd, but the leading coefficient could be positive or the leading coefficient could be negative. Those are the 2 cases. Now the total degree could be even and the leading coefficient could be positive, or the leading coefficient could be negative. These are the only 4 cases that's going to happen. Okay. So I'm going to show you the end behavior of these functions. If it's positive, if the degree is even and the coefficient is positive, for example, like 9x to the 6th power, here the degree is even and the coefficient 9 is positive. So they will both, the end will both face up. Okay, so every even degree, it's going to look like it's bouncing. There's a curve, like a bounce, Okay. If the leading coefficient is negative, for example, negative 6x to the 4th power. So the leading coefficient is negative 6, which is negative, and the degree is even. If that is the case, they both face down, both the beginning and the end. The end behavior of this graph or polynomial is going to be facing down. They're both going to be facing down. If it's odd positive, for example, if I have 9x to the 7th instead of 6 here makes it even, 7, the degree 7 makes it odd. So the degree is odd here and the leading coefficient is positive. That means from left to right the function will increase. So if this is a graph, it's going to come from here, go out over there like that through the origin. So that's one. The leading coefficient is odd positive, means it's going to start from here, the function is going to increase and come out there. If the leading coefficient is negative, if it is negative 9 x to the 7th power, negative, and the degree is odd, 7 or 5 or 3 or any odd number could be the degree. If that happens, from left to right, the function starting up here and it's decreasing, it's coming down. Okay, so odd positive is increasing, odd negative is decreasing. Even positive, they both face up, even negative, they both face down. Okay, so remember, even and odd, we're looking at the degree to see if they're even and odd. The degree tells you if it's even or odd. The leading coefficient, the first number of the x term, tells you if it's positive or negative. Okay, so here in this case 9 is not an even number. I'm looking at 6 to see if it's an even or not. So 6 is the degree. I'm looking at the degree to determine if it's even or not. I'm only looking at the 9 to see if it's positive or negative. Alright, so we have this is like our basic 4 shapes that we're going to get. So we have the case where the degree is 5 and the leading coefficient is positive. Okay, so our case is in this problem, our case is this. Degree is 5, means odd, leading coefficient is positive, so we are at this box right here. Okay, this one right here. So our graph is going to have all these x-intercepts. So let's say this is the number 0. So where are our x-intercepts? Well, I actually don't want to write the 0 there. I only want to write the x-intercepts there. So let's say this is 0. So half will be after 0. Half is somewhere here. 5 is somewhere here. 6 is somewhere here. Okay. And negative 3, let's say it's somewhere here. Roughly, not the correct exact spots. Okay. So now, this box says that about this function, that it's going to start somewhere here. Okay, it's from left to right, it's an increasing function, it's going to start somewhere here and it's going to go through all these zeros or x-intercepts. Another word for zero is x-intercept, remember that. Intercepts, except that x-intercepts up in the form of points. And it's going to come out over there. Alright, so my function is going to start over here. Now, I'm going to look at in order. The first root here is negative 3. So I'm going to start from negative 3. At negative 3, I'm going to look at the factor which gives me negative 3. This is a factor that gives me negative 3 as a solution. What is the degree of that individual factor. Now we are looking at individual degrees, not the degree as a whole. So here the degree of this factor is 1, which is an odd number. And remember, this is what every odd solution does. It cuts through to the other side of the quadrant, the x-axis. So at 3, instead of making a bounce, which would have been the case if it was an even degree, we are cutting through and we are going up. And the next point where I have to touch the graph is at half. So I have to take a U-turn. I'm going to turn around. I'm going to go try to touch half. But if I look at half, this is a factor that gives me half. What is the degree for that factor alone? It's again 1, which is an odd number. So we know that odds will cut through. So again at half, I'm going to cut down to the axis, take a U-turn. I'm going to try to go to 5 now. But now let's look at the factor that gives me 5 as a solution, which is this one. But the degree there is even. So the degree at 5 is not odd, it's even. Since it's even, we are going to start from here and we are going to make a bounce at 5. We're not going to cut through and go to above the x-axis, we're just going to make a bounce. And since the next number I have to touch is 6, I have to take a U-turn, and that's 6. At 6, the degree is odd, so I cut through and go up. So that is my end behavior. I don't have any other places where this graph is going to touch the x-axis because I do not have any more x-intercepts. So that's the end of the shape of this graph. Now this looks like it's not a perfect graph, it's just a rough graph. Now the only other thing we can actually predict from here is the nature of the y-intercept. A couple of other things we can know is the nature of the y-intercept. We know that we call this as the point 0, remember, to start with. So this is going to be our y-axis. This is going to be our x, and this is going to be our y, or f of x. Now we'll be able to say where this graph is going to touch the y-axis over there. So for that we have to find the y-intercept. We just have to find f of 0. Okay, so wherever we have x, we're going to plug in 0. So here, if x is 0, 2 times 0 is 0, minus 1 is just negative 1. If x is 0, we get a negative 5 to the second power. If x is 0, we have a 3. If x is 0, we have a negative 6. So all we have to do is multiply these numbers. We get where the graph is going to touch the y-axis. And we get the answer as, for this, when you multiply, that's a negative 1. Negative 5 squared is 25 times 3 times negative 6. We get the answer as positive 450. So that's where this is going to touch the y-axis. That's the y-intercept. Now we can also say that from negative infinity till 3, f of x is negative. It's below the x-axis. Where else is it below the which interval? Where else is it below? So from here, when x is between negative infinity to 3, f of x, this part is below the y-axis. From negative half all the way to 6, we have the entire graph below the y-axis. All this is below the y-axis. So the only place where f of x is above or positive or above the x-axis is from when x is between 3 and negative half. F of x is above. When x is from 6 to positive infinity, whatever number you pick, f of x is going to be positive or above the x-axis. So we can predict the nature of the of f of x. What kind is it, positive, negative, or whatever. And we can say that there's a relative maximum there, and there is relative minimums here. That's about it.